Today on How It's Made. Swiss Army knives. Player piano rolls. Oil tankers. And racing wheels. The Swiss Army knife is an entire toolkit in a pocket-sized package. This little multi-tool actually dates back to 1891 with the original Swiss soldier's knife. It wasn't long before it morphed into other versions for sale to the general public, and a century later, it continues to come in handy. Lost in the wilderness? Or are you a serious multitasker? Either way, a Swiss Army knife has tools to help you cope. Production starts with this big coil of stainless steel. Equipment pulls the steel between a press and a die. The press forces the steel against the die to punch out blade shapes. It also forms the finger groove for pulling the blade out of the handle. They mass-produce parts like can openers and pliers using the same technique. They load the blades into a vibrating mix of ceramic stones and water. The friction polishes the steel. A little powder keeps the parts from sticking together. After several hours, they activate a powerful magnet to extract the parts from the vibrating mass. The process has smoothed the blades significantly, but the metal is weak and dull. So a worker arranges the blades on a mesh conveyor, which goes into an oven that exposes them to intense heat. A quick cool-down follows, which toughens the steel considerably. The hardened blades now ride a carousel into a grinding station, which slims and trims them. That green liquid keeps them cool during this process. Afterwards, a computerized tool measures the blades. If the dimensions are even slightly off, they won't fit into the knife handle. A quick stamp gives the part its trademark name. To build the Swiss Army knife, they slide everything onto brass rivets, beginning with an aluminum spacer. A flat metal spring goes on next, followed by a can opener, a screwdriver, and an awl, a punch to make holes in leather. They stack another spacer and spring on top. They tamp it down and then slide a multi-purpose hook and a pair of scissors onto the rivets. Another divider, another spring, and then they add a wood saw to this multi-tool sandwich, because you never know when you might need one. They press fit the main blade, a corkscrew, and a smaller blade onto the assembly. One final spacer, and then they secure the rivets with attachments called bushings. Incredibly, they've packed 9 tools into a bundle that's just under an inch thick. They chop off the tops of the rivets to make them flush with the bushings, and then this spinning tool flattens them. The result is a multi-pronged tool that's virtually impossible to pull apart. The blade on the Swiss Army knife is thin compared to other pocket knives to allow it to fit into the casing. They grind the cutting edge to angle it at just under 15 degrees. This makes it razor sharp, ensuring there won't be many dull moments in this blade's lifetime. They measure the angled edge with a laser to verify that it's on the mark. And now it's time for the handle. It comes in 2 parts. They sandwich the tool bundle between them and press everything together. This embeds the bushings in the handle's holes for a tight installation. Amazingly, there's still space in this Swiss Army knife for a set of tweezers and a toothpick. Finally, they inspect every tool to confirm that it's in perfect condition and that it springs out of the handle as it's designed to. Making a Swiss Army knife is a job performed with almost military precision. There's no room for error when it comes to packing all these tools into a pocket-sized unit. And once they do, this multi-tool is ready to spring into action. The first self-playing piano system was invented around 1895. It sat in front of a regular piano, and the machine's wooden fingers would play the keys. Guiding those fingers was a roll of perforated paper. By the early 20th century, piano companies incorporated the roll mechanism right into the piano itself. The player piano rage petered out around 1930, but there are still plenty of old player pianos around, so there remains a market for the music rolls they play. The original roll-making method used a recording piano. As the musician played, each key would trigger a pneumatic valve which pressed a corresponding rod against piano roll paper over carbon paper. Then they just perforate the carbon marks. The modern method uses an electronic keyboard and a computer. As the musician plays, the computer converts the notes to data. The musician edits the data, then loads it into a computer that's hooked up to the roll perforator, a machine that produces 18 rolls simultaneously. Like the old recording machine, the roll perforator has a pneumatic valve for each note of the piano keyboard. As the computer activates each note, the corresponding valve triggers a steel punch to descend and pierce a hole in the passing paper. The longer the hole, the longer the note. Most music consists of multi-note chords, so the machine vibrates like crazy, punching many notes simultaneously. When the machine finishes perforating, the operator cuts off the paper and sticks on a temporary label bearing the song title. The paper then moves on to another area, where they permanently stamp on the title and other information. Here they slice the front end of the paper into a point. Meanwhile, this machine rivets brass eyelets onto an adhesive-backed polyethylene strip. Then around each eyelet, a die stamps out a tab. They stick one eyelet tab to the pointed tip of each roll. This tab end, as it's called, hooks into the mechanism of the player piano. A touch of cornstarch over any exposed adhesive prevents the papers from sticking to one another. When the music has lyrics, they print the words right on the rolls, so you can sing along as the piano plays. The first step is to make a lyric stencil, which requires cranking out each word letter by letter. The placement of words on the stencil is tricky because they have to synchronize with the notes. The stencil goes into a printer, which applies the lyrics with an ink roller. The last step is to roll up the rolls. They wind each one around a cardboard spool that has a plastic flange on each end. When you load a roll into the piano, you mount its flanges on holders, then hook the tab end to a spool that pulls the roll through the player mechanism. A rubber band to keep the roll from unraveling, then it's into a custom box. A machine shapes and hot glues sheets of ornately printed cardboard into the box tops. The finishing touch is a sticker with the title of the music. When a roll moves through a player piano, air flows through the perforations, triggering the corresponding pneumatic valves. Each valve pushes down the corresponding note. This factory produces more than 4,500 different song titles on player piano rolls, from classical favorites to top 10 hits. The first oil tanker was launched by the British in the latter part of the 19th century, and it fueled a revolution in transportation. These enormous ships now dominate the world's oceans. They move millions of tons of oil daily, and without them, most of the world's economies would be powerless. The life-size version of this tanker ship will be bigger than 2 football fields. It's so big that they build it in sections called grand blocks, which they assemble by crane in a dry dock. The process takes plenty of planning and engineering. They map out the job on a computer and assign a number to each of the 110,000 parts. In a big job like this, computer-coordinated labeling is the only way to go. They weld steel sheets to build the ship's hull. Sand placed on the seam melts during the welding to shield the seam from any contaminants in the air. Workers ready the structural steel beams. A robot places them at just the right spot on the welded section of the hull. Then an operator verifies that the placement is correct. More robots weld the beams to the hull section. Next, they submerge a steel plate in water. The water suppresses the noise and smoke from a plasma cutter as it carves holes in the steel. This steel plate will be part of the ballast tank. Some of the holes will allow water to flow through, while others lighten up the steel structure. The superheated plasma also cuts slits to interlock with the structural beams on the hull part. They then weld the assembly and install a top plate for a double-layered hull. Double hulls provide extra protection against oil spillage. After a paint job, powerful machinery transfers the double hull grand block to its final position on the side of the tanker. When fully assembled, the hull will have 12 cargo tanks with a total capacity of 14 million gallons. The engine section is situated at the stern of the tanker. It will take 3 diesel generators to power the ship's lighting, ventilation, and computer systems. They carefully lower each one onto the deck of the ship. A 10,000 horsepower diesel engine will be the tanker's driving force. Installing it is a very precise business. It has to be in just the right position to turn the massive propeller. 4 months later, the hull is complete, and the massive propeller is in position. It's all hands on deck to build the deck house, where crew will live for months at a time. There will be an incredible 10 miles of piping on this ship. Here, workers weld and bolt them to the deck grand blocks. It's an elaborate maze with an impressive master plan. They connect these pipes to the series of tanks in the hull so they can be used to load and unload cargo. Meanwhile, inside the hull, those cargo tanks are coming together. On the very bottom, the crew builds a network of heating coils. They'll be used to heat crude oil to a more fluid form so it can be pumped out of the tanks. Other workers grind welded seams on the ship's outer skin. This evens the surface for painting. The paint is an epoxy blend that resists corrosion in saltwater. They apply it in 3 or 4 layers and measure its thickness with a special ultrasonic gauge. In total, they spray more than 38,000 gallons of paint on this tanker. In this time-lapse video, our tanker comes together like toy building blocks in a matter of seconds. But as you've just learned, this is a complex job. It actually takes 16 months. A couple more months of testing, and this tanker should be good for the long haul. At first glance, a racing wheel doesn't look much different than a standard wheel. But look a little closer. There are subtle differences in the angles and contours that set it apart. They give it the strength to handle the extreme forces of racing and to corner well at high speed, which should have them cheering in the stands. The driver will get the trophy and the credit, but a good set of wheels is behind every win. They start with high-strength, low-alloy steel, which is a very stable material. The first of a series of die presses gives the center disc a concave profile and forms lug holes. The next press punches a hole for the hub and others called windows. Windows help cool the brakes while maintaining strength where needed. They stamp rings around the windows. This is called coining. The rings give the windows a nicer look, and the action compresses the steel to further strengthen the part. The next press is critical. It forces the disc into a bowl shape and gives it precise dimensions to accommodate brakes. The specific angles also reinforce the part. It has taken a lot of punching and pressing, but the center disc of this racing wheel has really taken shape. A smaller press now punches out the lug holes that were outlined earlier. These holes will allow the wheel to be mounted to a vehicle. Then the center disc goes for a spin as a series of tools trim it. The part is now complete. To make the rim, a machine unwinds coiled steel and rollers iron out the curl. A mechanical arm maintains slack as the flattened steel goes under the knife. The blade, called a shearer, cuts the steel to length and stamps product information onto it in one swoop. An operator now winds the steel between 3 rollers to twist it into a band. He then places the band into the jaws of a welder, which fuses the 2 ends together. He then slides the band into a machine that scrapes off excess material from the weld. It's still warm, so it can be easily removed. Now, the band comes under some serious pressure as a machine forces it around dies at both ends to create flares. This rack transfers the rim to a series of rollers, which shape its inner ledge. This part of the rim is called the bead seat, and it will be attached to the bead wall of the tire. They trim the rim to make the edges neater. This finishes off the part. They nestle the center disc loosely in the rim. As the rim spins, they heat the outside with a torch. This causes the steel to expand, and the center disc drops further into the rim. As the rim cools, it contracts, shrinking to the center part. The 2 parts are now interconnected, and a welding job makes the bond permanent. a worker drills threaded holes onto the wheel to attach valve stems. As it exits, the drill turns in reverse so it doesn't wreck the threads. After a fresh coat of paint, they apply a thread locking adhesive to the valve stems and screw them into the holes. The valves will be used to add air to the tires. The wheel rotates as a small roller paints a stripe onto the rim for accent. Then a press stamps a number onto it to identify this wheel in the event of a problem. And now this wheel is on a fast track to the finish line.